Hello, in this video, we're going to talk about string. We're going to talk about string indexing, string slicing, string formatting, and various string methods. So now let's start with string. So for example, we have this variable A. The A is written on the left-hand side, and that signifies that it's a variable and it has this data written inside of it. That's algorithm and machine learning. Having the double quotation mark, that's your data that is stored in variable A. If we want to print A, right, that it just gives us what we have inside of variable A. Now, can we print out the length of the number of characters that are in that data? How do we print out the number of characters in that data? All you need to do is print length of A and you run it, and that's 31. So by number of characters, it has included the alphabet and also the spaces in between the alphabets, right? If there are other characters like apostrophe, question mark, so let me add a question mark here and see what that's going to look like. It's going to add that also. So you have 32. If I add some space and I run it, you're going to have 37. So it counted all the spaces. So by characters, it included the alphabet and also the spaces and other features that are in the data, right? So that's the first thing we did. We tried to count the number of characters that are in the data stored in the variable. Now let's talk about positive indexing. By indexing, we mean the positioning of a particular character in a string, right? So we have this string here because it has this double quotation mark, and then there are 3 words written in it. So there are several characters in here. We have S, T, A, T, I, S, C, I, C, S. Then there's a space, there's A, there's N, there's D, there's another space, there's P, there's Y, there's T, there's H, there's O, there's N. So there are several characters in there. And by indexing, we mean the positioning of each of these characters in this string. So indexing starts with 0. For positive indexing, it starts with 0. So this S, the first S alphabet here, will have the 0 index. This T has the 1 index. A will be 2, T will be 3, I will be 4, S will be 5, T will be 6, I will be 7. So now let's say print C, right? That was a capital C, and we have to make sure that we. It prints out 36 in Python, which is what was stored in variable C. Now let's print C at 5th position, right? The challenge, there was an error. This should be small letter P. Okay. Yeah, the 5th position is an S, right? S is 1, 2, 3, 4, 5. So sorry, 0, 1, 2, 3, 4, 5, right? So let's print for variable C, the one that is in position 10. It's a space, right? This is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9. The space is a 10th one. So let's print the one that is on the 13th position. We have D. So this is D. That shows that D is in the 13th position. That's all about positive indexing for strings, sorry. Yeah. So for the negative indexing, it's also about the positioning of each of the characters in the string. But this time around, it's going to start from the left-hand side. The positive indexing starts from the from the left-hand side, and it starts with 0, 1, 2. But now the negative indexing will start from the right-hand side, and it's going to start with -1, -2, -3. For example, statistics and Python is a string with the double quotation mark. N is going to be -1, O is going to be -2, H is going to be -3, T is going to be -4, Y is going to be -5, P is going to be -6, and this space is going to be -7, and then this D is going to be -8, this N is going to be -9, and A is going to be -10. Let's see how that works. Print C -9, run it, we have N. So it's definitely not this one. Let's print of -1. It's still N. Let's print of -2. It's O. So this -1, this -2. Let's print of -3. Oh. It's H. We print of -4. It's T. Print of -6. We expect P, right? And that is it. So that's negative indexing in Spring. Now we head over to slicing. So in slicing, there is positive slicing, and there is also negative slicing. So we start with the positive slicing and see what that looks like. So slicing is just about being able to get out some portion of your data. Say you have a variable, for example, you have this variable C, and we have this data stored in this variable. To slice this variable means to get out some portion of this data, right? For example, we have the input as statistics and Python, but we just need and, right? If we have the input as statistics and Python, we just need S and T and P and N. How do we do that? So that's what slicing, that's what we can do with slicing, okay? So let's play around it. Print. We want to print variable C, but there is a column. This is a symbol for slicing. This column and this straight bracket. If you do this, before the column, there's nothing written, and after the column, nothing was written. That means there is no starting point and there is no ending point. So if you run that, it's just going to give you the data that was stored in the variable. But if you specify, say you specify 0 to be the starting point and you write 5 as the ending point, if you use 5 as the ending point, that means it's going to start from 0 and it's going to stop at 4, right? 0 is S, 1 is T, A is 2, T is 3, I is 4. So you're going to have static, right? Let's run that and see what we have. That is static. So if we do something like 0 to 12, it's just going to give you statics, then the space and this A. So it counted from here 0, 1, 2, 3, 4, 5. So by this, you're able to interpret what your prompts are doing when you're writing a code. We can also start from 6. So that means 6 to 11, right? So 0, 1, 2, 3, 4, 5, 6. So it started from T, and 7 is I, C is 8, S is 9, the space is 10, and A is 11. So that's how we have that, okay? So that's it with positive slicing of strings. So before we go on with other things, we can actually also have something like this: print C, straight brackets, nothing in front, then a colon, then 10. So what it is going to do is just going to start from the beginning and stop at 9. And we can also have something like print C, straight brackets, 12, the colon, then nothing. It's going to start from 12 and it's going to go right here to the end, right? Okay. For the negative slicing, it's just like the negative indexing. It's going to start from the right and all the way to the left side. You're going to start with n, and this time around, it's not going to start with 0. It's going to start with -1, -2, -3, -4, -5. So let's try that out and see what we would have. It would print. We're going to print C, but we want just a section, just a portion of that data as an output. And see, we have this, and we stop at -6. If you're stopping at -6, -7 is greater than -6. 7 is greater than 6, but -7 is less than -6, right? 7 is greater than 6, but -7 is less than -6. So it's gonna start, let's say the starting point is 0, the end point is -6. So it's gonna stop at -7. So -1, -2, -3, -4, -5, -6, -7. That is D. It's going to stop there. So it started from, if you didn't put anything, it's going to assume the positive side, 0, but it's going to stop at the character that has the -7 index. Okay? Let's try another one. Let's put something in front this time around. Straight bracket, and we have -4, and then we have this column, and then we have, let's do the same -6 and see what we have. -4 is what? -1, -2, -3, -4. -4 is T, right? And if we want to stop at -5, sorry, at -6, that means we want to actually stop at -7. That's to D. So we expect T, Y, P, D, right? So we try to run this, but we're not getting an answer. -4, we expected it to start from -4 and stop at -8. We have -7 here, that means it's going to stop at -8. So -4 is -1, -2, -3, -4, which is T, right? -8 is actually towards the left. It doesn't work that way. It works towards the right. So it will be impossible to go to the left by this method. Like that's why it wasn't running. So if I switch this around, if I have -7 and I have -4, so -7 is -1, -3, -4, -5, -6 is the space. It's going to start from this space, then it's going to go to the right. So this was -4 was T. So we're going to have the space P, Y, and T. Let's run that and see. Yeah. Oh, sorry. It should stop at -5 because this is -4, right? -7 and -4 is going to start from this space because this is -1, -2, -3, -4, -5, -6, -7. It's going to start from this space, and then this is -4. This is the end, then that means it's going to be -5. It's going to stop at -5. This is -1, -2, -3, -4, -5. -5 is Y, so we expect the space, the P, and the Y. Let's do something else. Print C straight, and then we have -9, and then we have -2. So we expect it to start at -9. This is -9, and it's -9 because you come from here, -1, -2, -3, -4, -5, -6, -7, -8, -9 is n, right? And if you expect it to stop at -2, so that means it's definitely going to stop at -3. So -1, -2, -3. So it's going to stop at H. So let's run that and see what we have. So we have N, D, B, Y, T, H. Okay. Yep. We can actually also have something of this sort. Let's see, straight. And then we have -9, and then you have the column, and you run it. It's just going to go all the way to the end, right? Then also have something of this sort. See, you have We have nothing first, then we have this, then we have -2. Then we run that. So you're just going to start from all the way from this place to the point of -3. -1, -2, -3. It's going to stop at h, and that's what we have here. Okay. So now we're going to talk about reverse by negative slicing. And it's a little bit different from positive or negative slicing. This is a reverse case. Okay, let's see how that works. Print C, straight brackets, 2 columns. This is what differentiates it. For the positive and negative slicing, you had to use just 1 column. But here you're going to use 2 columns. And then there can be a number in front and there can be a number at the back. Let's just do this and see what we're going to have. It's just going to give you what you had there because there was no specific indexing involved. But now let's start with -1 on this side and let's see what we're going to have. Please look at what it's a reverse because if you look at this NOHTYP statistic, so you just wrote out this backwards and it started from this N and it goes OHTYP. So let me try -2 and see what that's going to give us. I have this capital C, that's the variable. I have the straight bracket and I have my double column and I have -2. Okay, let me also write for -3. Let's see what that's going to look like. And let's run everything at once and see we have, can you see that there is some form of difference? This give everything, if you read backward, this is statistics and Python, this is something different, this is another thing different. Let's do -4 and let's see what's gonna give us straight brackets, 2 columns, -4. And let's do -5. And let's do -6. And let's run everything. And can you see the way it just reduces downwards? Let's try again. Let's do this. See, 2 columns, -7. Let's see, -8. Okay, you can see. All right, so let's try to see what happened here. So -1, it definitely started from this -1 index here, -1 position, -1, -2, -3, you know, everything backwards. For -2, we have this. So what happened? It started from N, obviously. It's always going to start from the first one. See, for all the answers we got, it started from N. So for the reverse slicing, reverse by negative slicing, it's always going to start with this last character here before the jumping. So by reverse slicing, it kind of jumps based on the number you put in here. So it's going to start from the last character because there was no number in front of this. There was no number in front of this double column. So that means it's going to start from the last character. And then it's going to start from the back and not from the front because there are 2 columns. So that's a reverse slicing. Okay. Now, -2, what does that signify? After this -1, it counts 2. 1, 2. It goes to, that is H. After H, you count 1, 2 again. 1, 2, and that is the Y you have here, right? After Y, you count 1, 2 again. 1, 2, and that's the space you have here, right? After the space, you count 1, 2, and that's the end that you have here, right? And after this, you count 1, 2, 1, 2, and that's the space that you have here. And after that space, you can't, you know what, I think it may be a little bit bulky. Let me just, let me, okay, so that we can have a clearer view of what I'm talking about. Let me start again. It's a negative slicing. There are two columns and we have -2 here. So the minus sign, we have -2, right? It's a negative slicing. It starts on the last character because there's no number in front of these two columns. The first character is N, right? And then we count two characters, 1, 2. That would fall on H. That's why you have H here. If you count another two characters, 1, 2, it falls on Y, and that's why we have Y here. After Y, count two more characters, 1, 2. It falls on the space, and that's why you have the space here. After the space, you have two characters, D and N. It falls on N, and that's why you have this N. After N, you count two characters, A and space, and that's why you have the space here. After the space, count two characters, it falls on C, and that's why you have C. After the C, you count two characters, it falls on T, that's why you have T here. After this space, you count two characters, S and I, it falls on I, and that's why you have I here. After this, you count two characters, T and A, that's why you have this A here. And after that, you count two characters, T and S, and that's why you have this S here. So that's how we came about that. Let's try -4. Excuse me. So for -4, it's also going to start from this last one. You have your N. So after N, you're going to count 4 characters. 1, 2, 3, 4. It falls on Y. That's why you have Y here. After Y, count 4 characters. 1, 2, 3, 4. It falls on N. That's why you have this N here. After that, you count 4 characters. A, 1, 2, 3, 4. It falls on C. That's why you have C here. After that, you count 4 more characters. 1, 2, 3, 4. That's why you have I here. After that, count 4 more characters. T, A, T, S. That's why you have this here. Let's go to 6. We're starting from N. It's a negative slide, reverse negative slicing. And start from N because there's no number in front here. That's why it's going to assume the first character from the back and start from N. You're going to count 6 characters. 1, 2, 3, 4, 5. It falls on the space, and that's why you have the space here. After the space, count another 6 characters. You have 1, 2, 3, 4, 5, 6. Falls on C. That's why we have C here. After C, you count 6 characters. 1, 2, 3, 4, 5, 6, and that's why we have A. After A, 1, 2, we don't have up to 6, and that's why it stops there. Okay. If we'll just keep doing that, that's how it works. Okay, that's the essence of this to allow you to understand how this works. Okay, let's have more variation of that. Let's say we have a number in front here. If we have 2, what's going to happen? That means we have 2, then this double column means that there is a reverse slicing, and this 6 means that you have to count 6 characters before writing out the character you want to write. So what is 2? 0, 1, 2, right? It's going to start with that character you have there, A. So if it counts backward, we don't have up to 6 characters backward, so it just stops there. So let's try to start from somewhere around here. Let's say 12. So where is 12? This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 is at N, and that's why we start from N. So it's going to start from N, and it's going to count 6 backwards. 1, 2, 3, 4, 5, 6. It falls on T. That's why we have T. And after that, we're going to count another 6 backwards. 1, 2, 3, 4, 5, 6. It falls on S, and that's why we have S here. So you can actually also start with the negative number. Let's say -9, and let's see what that's going to give us. We're having it has NTS. So where is -9? This is -1, -2, -3, and this is -4, this is -5, -6, -7, -8, -9. -9 is on N, right? So that means you start with N. So you're going to write your N here as it's given us here. So from N, you're going to count 6 backwards. 1, 2, 3, 4, 5, 6. So it falls on T. That's why you have T after N. And then you're going to count another 6 backwards. 1, 2, 3, 4, 5, 6. It falls on S. Okay, let's go ahead. Okay, let's try to look at reverse by positive slicing. Again, with the double column shows that it's a kind of jumping slicing. They're going to jump how many times? 9 times. So now there is no negative sign here. That means it's a positive slicing. So again, here we don't have any number in front of the double column. So it's going to start from the first character, which is S. And this is a positive slicing. There are no negative. If this number at this right-hand side has no negative um, sign, that shows you the positive slicing. If this number here at this right-hand side has a negative sign, that shows that it's going to be a negative slicing. And for a negative slicing, you count backward. But for a positive slicing, you count forward. For negative slicing, you count from the right to the left. For positive slicing, you count from the left to the right. Okay. So the number, the sign on the So when there are double columns, that means there's a reverse slicing. To know if it's a positive slicing or negative slicing, you look at the sign on the right-hand side after the double column, okay? The sign here determines if it's a positive slicing or a negative slicing. Now here, this is a positive slicing, and this is the positive, there's no negative sign. That means it's going to be a positive slicing. And again, there's no number here, so it's going to start with this, the first one, S. Take note that for this, when we had the negative slicing and there was no number, where did it start from? It started from this -1. It started from this last from the right, right? So if there are 2 columns, then you have a reverse slicing. If there are 2 columns, you have reverse slicing. If you have, on the number on your right, if you have a negative sign, that means it's a negative slicing. And if it's a negative slicing, your first character will be the first character on your right. But if you have a positive slicing, like in the case of this, your first character will be your first character on your left, if there's no number here, okay? All right, let's see what this gives us. So if we have SSH, the first one is S, and then we have you count 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. It falls on S. We have S. And after that, you count 9 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9. It falls on H. And that's why we have H here. Okay. And we can just try. Let's do 5. SSPN. So again, that would just be S first, then you have 1, 2, 3, 4, 5, it falls on S, you write that down. Then you have 1, 2, 3, 4, 5, it falls on the space, you write it, that's why you have the space, and then you count 1, 2, 3, 4, 5, it falls on P, you have P, then you count 1, 2, 3, 4, 5, it falls on N. It's also possible to have a negative sign in front here. So here we just have, oh, how did that come about? If you have -2 on this left-hand side, that means you want it to start from -2. This is O, right? -1, -2. O is so O is occupying the -2. So if you now this is a positive slicing, and you should count forward, right? So after O, there's just one character, so nothing is there. So that's why we only have O, the letter O written out. Let's start with, let's say something around this place would be -10, right? Let's do -10 and see what we're gonna have. So This is minus 1 minus 2 minus 3, 4, 5, 6, 7, 8, 9, 10. Minus 10 started from A, right? So it's a positive slicing. We are moving forward. It should be 1, 2, 3, 4, 5. That's the stop at Y. That's why you have Y. Then after that, count 5, 1, 2, 3, 4. It stops there. So there is no more character to make up for that. All right. Can actually also have like something like 1. So that means it's gonna this is 0, this is 1. Gonna start by from T, then it's gonna count. So let's run that and see what we have. So it started from T, then you have 1, 2, 3, 4, 5. You have another T, and 1, 2, 3, 4, 5. You have A, and then 1, 2, 3, 4, 5. You have Y, and after Y, you don't have up to 5 characters. So that's why I stopped there. So you could start from 3, and you could do 3, 3, something like that. So it's going to start from the 1, 0, 1, 2, 3. It's going to start from the T, and then it's going to always count 3, 1, 2, 3, then 1, 2, 3, and then 1, 2, 3. That's why you have N, and then 1, 2, 3. That's why you have P. 1, 2, 3. That's why you have H. You stop at H because you don't have up to 3 characters left. Okay. Yep, yep. Okay, let's play around that and see what we can get from indexing and slicing. Say you have this data stored in this variable B. We use statistics and Python to analyze big data and create predictive models. So this is a string that was stored in that variable, and we want to extract some part of this data. We don't want everything at the output. First, let's try to check the length of of data. How long is it? 78. So we have 78 characters in there. Say we want to just extract this first one. So we could just say print, this first, we use statistics and Python. If we want to extract this, let's just eyeball it. This would be something around the straight bracket, this column, let's say 20, and let's see what that's going to be. See, we use statistics, and let's make it 30. Okay, just a little bit too much. Let's make it 28. And okay, we use 36 and Python. So that's just one of the things you could do with that. Let's say 50. We use statistics and Python to analyze big data. Let's get rid of that. Let's say 48. We use statistics and Python to analyze big data. Okay, now if we just want to extract this analyze big data, let's see 30. Okay, we're close. Let's say 32. There you go, 32. 48 give us analyze big data, right? Let's do predictive models. Since the length is 78, and we expect that to be somewhere around, say, 50. Okay. All right. So this will be, let's say, 53. Create predictive models. So yeah, that's one of the things you do with this. Oh, there was a space here. That means we have counted that space. That still works. Yep. So now we head over to string formatting string formatting or interpolation. And let's see what we can do with that. So this is just a way of using variables within a string. Okay. All right. So by string formatting, I said we're going to use variables within a string. So we have the string that's like a sentence like what we had here. And now we created variables from those sentence. Like we have this stability stored as 2, 1, Python stored as 2, 2, big data stored as an object 1, predictive model stored as results. These are the variables that we insert into the string. Let me take this off. So we use, this is a string, this is a variable, this is a string, this is a variable, this is a string, this is a variable, this is a string, and this is a variable. And this comma are concatenation tools that helps to match everything together. You could also use the plus, excuse me, you could also use the plus sign for that. So if we just run this, it's going to write what it's going to replace this to 1, the variable with the data that is actually stored in them. We use statistics and Python to analyze big data and create predictive models, right? Which is what result was predictive models. So that's just some. So there are different ways to do this. This is one of the most, looks a little bit tedious, well, yeah, but there are other easier ways to get this done, and we're going to look at that right now. Okay, let's look at the string format method. So for the string format method, if we have all this data stored as these variables already, let me just put them here. So you have this stored as a variable already, and all you need to do is print, just print this whole thing as one sentence. For this format, you don't need to use this number of double quotation marks as was needed here, because this is a string, this is a variable, you have to concatenate, you have to differentiate between these and these, you have to use a comma and all that. You don't need to do that. Just what all you need to do is to just write the sentence just as one sentence. So we use this curly bracket and this curly bracket to analyze this curly bracket and create this curly bracket. Then you have just two double quotation marks. You could actually use a single quotation mark if you want to. So the quotation mark is very important to show that this is a string, but you don't need to use it. You don't need the concatenation here. All you need to do is just say dot format to 1 to 2 object 1 result. So one other thing is that for this method, the ordering of these variables that are written after the format word is very important, because it's going to fill in this curly bracket according to the order of this variable written here. So after writing it that, we're just going to run it, and you have this. We use statistics and Python to analyze big data. Let's put a space here and see if that's going to help a bit. To analyze big data, let's leave a space here also and see big data and create, let's leave a space here, no, a space here would help, and create predictive models. Let's see what happens if we fail to put that quotation mark. See, it's going to be an error. See, it's unterminated string lateral. So you have to make sure that you put the double quotation mark, either single or double, to avoid errors. Okay, let's look at the next. This is the string format method. Let's see the next method for string formatting. So beyond the string formatting with variables, you could also perform some mathematical operation within the string. Say, for example, I have this variable item1 as smart1. The smartphone is data that I stored in that variable. Gaming console is item2. Number of items 5, price for 1,000. I could write this sentence. I want to buy curly bracket at the rate of curly bracket dollar. So number of items will be the first one. The second one will be item2. And then the price for 1 at the rate of this will be the third one. At the rate of this. So if we run that, I want to buy 5 gaming consoles. Let me just item 1. That will make more sense. I want to buy smartphone at the rate of $5,000. The rate should be the amount of each of them, right? So you could just take this one off, $1,000, or if you want to do the 5 thing. I mean, just trying to show you that you could do some further manipulation apart from just string formatting. You could actually manipulate the variable and the data you store in there with a sentence, right? Okay. The next one we're going to look at is the indexing or positional arguments. We have all the data stored in the variables, statistics as tool1, Python as tool2, big data as object1, predictive models as result. It just looks almost the same thing as the other one with the formatting method. But the difference is that there is some form of indexation. We have numbers inside the curly brackets. So for this, we don't have to be very careful about the ordering of the variables in this bracket. So for example, we have tools2, tools1, result, object1. However, we prefer to have tools1 written here, we want tools2 written here, we want object1 written here, and we want to have the results written here, right? But we just arrange this within this, the order doesn't tally with the curly bracket. So what we do is to just number this variable. This will be 0, this will be 1, this will be 2, this will be 3. So we want this one that is 2, we want it to be here. Then this one that is 3, we want that will be this one, we tally with this 3. And then 0 we tally with 2, 2, and 1 we tally with 2, 1. Okay, so we print that. If we run that, so see we use statistics and Python to analyze big data and create predictive models. So what it just literally did was that it's filled this curly bracket with the right indexation. This 1 to 1 is, this is 0 to 2. We have it, that's Python. To 2 is Python, that's why we have it here. So that's what it just matched it accordingly based on the positions of the variables in the format bracket. All right. Okay, so here is the keyword argument method. It's a keyword argument, so you just have your string reading out. We use this, then you put in the name, the variable inside the curly bracket, put the variable inside the curly bracket, put the variable inside the curly bracket, just like that. But when you click in right format, you now interpret what each variable stands for. So that's why we say the keyword argument. And let me take off the comments and try to run that. Let me see. Just while doing this, don't forget that this format, this bracket, is different from the bracket of the string itself, right? Yeah, so that could be an error if you just, because there are 2 brackets, right? We have, so let me make this smaller so you see what I'm saying. So there are 2 brackets. We have the first bracket for the string itself, and that ends with this, right? Then we have the second bracket for the format inside it, of this. If it's just one bracket closing here, there's going to be an error, okay? Let's take a look at that. So let's try to run this and see what we have. So we use statistics and Python to analyze objects, to analyze big data and create predictive models. Let's see if the ordering is a big deal here. Let's see what happens if it's not ordered according to, let's see if indexing has excuse me, if indexing would affect this. Let's cause this and put it here and try to run it again. Okay, indexing is not a thing here. It doesn't have to be in the same order. Like, you just need to put in the right. Once you have the keyword argument well tallied, then you have what you need to have. Okay, so this is just another method. Let's go on with the next one. Okay, so this is yet another method. We call it the f-string method, or the string literal. So what you need to do here is you print, for example, you want to say you're welcome, you have your name. It's just like a keyword argument, but you don't have to format written outside of that. There should be an F here. You have the name and say from, then you have look. Oh, there's an arrow. Invert. So there is an error because we forgot to put in the quotation marks that shows that that is that's the data that is stored in on a variable. So there you go. You're welcome to do from United States, or you can put from the United States. Yeah. So this method is the F string method. You just have this F written before the string, and then you have the variable, the keyword inside the curly brackets in the string, and then you have this already written out before then, and it gives you what you need to have. This is another method. Let's go on to the next one. So this one is using template class. For this, you first have to import templates from string. So first of all, import templates, and then so for the template class method, we first imported a template, and then we have this some data stored in the variable name and location. Then we have, for example, let's say this is a welcome note. You have to write template first, and then put in a bracket. You welcome $ R1. This could be another. This R1 could be just anything you want to use, and from the $R2. Then after that, you could just use just another variable. Let's say we call this A. Let's call it A because we already use R. A will be this welcome note dot substitute R1 to be name and R2 to be location. Now let's print A and see what we have. You have your welcome Codil and from the United States. Let's see if we say R1 is low location and R2 is name. It's just going to switch it. You're welcome, United States from the code. So that doesn't make sense. So that's how it works. It's a little bit more tedious, but it's just another way of doing it. And it's okay to know all the methods that are available. Rather than using the variable as we did here, I mean, rather than using the variable, we can just use the string directly. Like, just say R1, want R1 to be Codil, and you want R2 to be United States. And you're right, and I'm just gonna give it straight ahead. So there are situations that might warrant you to use the variable, or other situations that might warrant you to use the string just straight up. Okay, so the purpose of using the variable instead of the string is to allow for diversification of variability. Yeah, just as the name implies, variable. So you could have anything stored in this variable. So for example, if you want to change something here, you don't need to tamper with this. You only need to tamper with this. Okay, yeah. Before we go ahead, I just want to draw our attention to something when it comes to using um, double strings and double quotation mark and single quotation mark. For example, let me say print my mom's My mom's shoes about are the same size as mine. This quotation marks shows that it's a string, right? But because there's an apostrophe here or some form of quotation mark here, there will be some yeah, it's just gonna give an error, right? So it's better to just once you have a single quotation mark inside, you rather use a double quotation mark so that there's no confusion. Can you see? Okay. So now we're gonna talk about escape characters. Escape characters. So escape characters would just literally like you have like four sentences to write to help you to arrange the sentences as you want them to be arranged. We're gonna see how that works as we go on now. Okay, let's have some sentences really written down. Let's say brings. Um, so let's say we have the sentence. I like to code. Python is a versatile programming language. Data science is a predictive tool. We have this as a string and I print it and it's just gonna write it all out like this. I like to code. Python is a versatile programming language. Data science is a predictive tool. Let's see, we can write that out in a different way. Okay. This is where the escape characters come in. Say we could just separate each of those sentences by forward slash and in. I like to code. Python is a versatile programming language, or wherever you want to separate the sentence. It doesn't have to be at the end of a sensible sentence, just wherever you choose to. And let's run that. Can you see what it did? I like to code, but why is it given that space over there? Let's look into that. Let's close this up and see what's going to, okay. So if you don't want any space after that, we should close up the spaces here. Let's close up the space also. And yeah, I like to code. Python is a versatile programming language. Data science is a predictive tool, right? Okay, let's see if we can also have that some other ways of doing this. Um, if you have a double forward slash, what's that gonna be like? That's another escape character. What this does is that it just separates each of those sentences with a forward slash. Let's see if we close up this space in here and see how that will influence the outputs. Okay, it just closes it up. It just separates everything with a forward slash. Using double forward slash, we just separate each of those portion of the string with a forward slash. Okay. Now let's look at the next one. Let's do forward slash T and run that. So what it does is that it separates each of this portion of the string with just like when you press tabs button, that amount of space is what you have here. This an amount of space is what you're gonna have here. And then there's yet another one. Um, if we say R, so what this is going to do is that it's let me take this off before I do that. Okay, what this is going to do is that it's just going to write out what is in front of the slash R. everything behind it will be forgotten. We're just gonna write out what's in front of that slash R. So let's put this slash R somewhere else. Let's put it here and see what we have. /R. See, everything in front is written out. Okay, that's what this /R means, and that's it for escape character. Now we're gonna head on to string methods. Methods in string. Let's say we have this string and that is stored in this variable. I call it D string. I love to code. Python is a versatile programming language. Let's see how we can use different string methods. Let's say print, let's just print what we have there. Print the string. What I'm gonna have, it's just gonna give us what we have in there, right? Now let's try print the string dot upper, right? Print the string dot upper. What does that do? It just rewrites everything in the upper casing. Okay, that's what it does. It rewrites everything in the upper casing. Let's print, let's try another thing. The string dot lower. It's going to rewrite everything in the lower casing. Take note, I have this in upper casing, lower casing, upper casing with lower casing, just to make sure so that we could play around the string methods. So if we have dot lower, just like saying print the string, but everything should be in lower case. Okay. Let's see something else. Print the string, but not this time around, not upper, and print the string and find the word code. Print the string, print this, and find code. Let's see what that is going to give us when we run it. It says -1. What does that mean? It means that it's not in this sentence. And that's true because the code that is written here is in uppercase and this was lowercase. So if I say print the string dot lower dot find this, that's gonna be okay. So what I'm gonna do is write it in uppercase and run it. Print the string dot find this code. So it's just telling me that the position is on 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the first letter in code is on position 10. That's what it just did. Okay. So let's try something else. Let's try and copy that. There's another way to do that. Print the string index, because index and position is still the same thing. You're still gonna get 10. So they're the same thing. If I use the small letters, it's gonna give us an error. So that's another thing that differentiates between find and index. Even though that both of them can do essentially the same thing in finding the indexing or positioning of the first character in the major string. So this code, we can refer to it as a substring, right? Finding the positioning or substring or indexing of the substring in the major string. That's what find and index does. But the difference between them is that if the string is not present in the major string, find would return a -1 as the answer. Say we have this. So find will give you -1, but index will just give you an error. That's if your substring, the substring that is requested for, is not in the major string. Okay. Okay, let's try one more thing. Let me comment on this and comment on this. Print the string dot title. Let's see what that looks like. Can you see what that has done? We had the string written out again, but this time the first character of each word was capitalized. That's what title does. It capitalizes the first character, the first letter. I mean the first letter, not the first character. The first letter of each of the words were capitalized. Okay, so that's the function of title. And let's see, capitalize. What will capitalize do? Capitalize did something different. It just removed all the uppercasing and made everything the same thing. Like just put everything. It just, the only difference is that you have the first word is a capital while the other words are in lower casing. Okay, so that's different. Let me uncomment this. And so this is the result for title. This is the result for title. So each of the words have their first letter in uppercasing, but for capitalize, only the first word is in uppercasing, or the first letter is in uppercasing, while the, let me change this and so that we can see the impact of that. Let me see. This is just the first letter of the first word that will be capitalized, that will be in uppercasing if you are using capitalized method, but the others will be in lowercasing. Okay. All right. Okay, let's do something. Let's go on with the string methods. And let's say this is a string, and the string we have is I love to code. I learned Python, and that has helped me to code. So we want to do something now. Let's say print um print a string dot count word code. There's an error. There should be a string here. It should be a quotation mark. Okay. So what this does is that it counted how many times code appeared inside this inside the string. So again, this is a substring and this is the major string. So it's just going to count how many times the substring appears inside major string. So that's just what count does. Also, we can do this, print the length, that's the count how many characters are present in there. So we could also do that as we did for the indexing and slicing. So we could do all that here. Like get out. We could slice this, try to get out just this, or just trying to get out this by using positive or negative indexing and slicing. Okay. Okay, let's do one more thing. Let's say B string is, so I'm intentional about ensuring that all the characters are in lower casing. So let's say print, if one, we can ask to know if the string is written in upper casing or lower casing, just by saying it's lower. So that's a question, and the answer will be in the Boolean format. Boolean is true or false. So let's bring this, it's true. If I change this to capital I and I say it's lower, it's going to be false because there's an upper casing and there's also a lower casing. All right. So let me replace it small with the lower casing. Let me say, let me do that again. So now it's going to be true because they are all in lower casing. If we say it's upper, it's just like a question. Is it lower? Yes, that's true. Is it upper? False, because they are all in lower casing. All right. Another thing is trying to know what it ends with or what it starts with. This can say starts with, this is this is specific. It's not just any word, right? Starts with um let's say how, and I run, it's gonna give, it gave us an error. Where's the problem? It said that did not defined. Okay, let me we should always put this in a string. Sorry, I mean in a quotation mark. Mm. So I'm asking, does it start? This is B string. I said, does it start with har? It says false. That's no. So this is that will start with I. Let me use I. Does it start with I? True. If I use a capital I, it's gonna give the false because the upper casing is different from the lower casing. So apart from that, we can also check for what it ends with. B string ends with, let me see, help. Says false. Helped. True. Let's say by two, it's gonna be false, but that's not what it ends with. So this is what it ends with and what it starts with. So this is actually in, there's a specific word. It has to be ends with. If you say end with, it's gonna give you an error. So you have to write the right thing. Ends with. So it's not just English language. It's these are inbuilt modules that is used for the string method. Okay. So there's another method called the strip method. It strips the string of unnecessary spaces, either before the first character or after the last character. There is the first character here is an I. So let's say I put in some unnecessary space here, and I also put in some unnecessary space here. So if I want to find out the length of that, it says 66, right? So now if I print B string, now B string is just any word. I just used it, right? You can use any word. The variable can be anything you choose. And I say strip. Can you see? It has stripped it of all these unnecessary spaces. Now, if before I stripped it, if I say print B string, it's going to write it with the spaces here because the space is also a character. It's going to print it out with the character in front and definitely the character behind after it. Okay, so we don't want this. If we don't want the spaces, so if you don't want the spaces, all you need to do is what we did here, and that's another method, strip it of the space. And so we have this. So now let's count the character after the stripping. Okay, something is not right. So we've seen the impact of stripping it, and so let's just recalibrate. So now we say B string will be equal to B string dot strip so that it recognizes the. So after this, you say print B string. So it's going to do the right thing, okay? And now let's print the new length. It should be 51. It should be reduced. If we print the length before the stripping and after the stripping, see that will be different. So before the stripping, it was 66 because of the spaces, and this was what it was because of the spaces. It was 66 and it has the space and the space behind it. But now after the stripping and after recalibrating, B string will now be equal to B string dot strip. Then you print B string and print the length of it. We see the reduction in the amount of character in that string. Okay. So we're gonna do one more thing here. One other method in string is a split method, and we're gonna split a string with respect to the characters that are in that string. For example, here I have this letter is a character, this space is a character, this comma is a character, this letter is a character. Let's say we want to split that based on the character I, right? Let's see how that's gonna work. That's how it works. Like you can split with just a space or with a particular. Now let's say print B string. Can you see? I have to code. Then there's a space. Then there is I. This is what we're using to split. And then this other one is written. So you just splitted it based on this character. We can split based on the space because there's a space here. Oh wait, before we do that, let me after after splitting with I, let's print the length. Print the length. would be, I want to see how many characters will be recorded here. So it records that as two characters. So we just categorize everything here as one and categorize everything here as two. So that's what it did. So let's say we are splitting with a space because there's a space here, there's a space here, there's a space here, there's a space, 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 space. So if you're splitting with that space, let's see what that's going to give us. So you have this I, then it brings out this R, two, four, I, lines, Python, and so, and also count everything 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you have no 1, 2, 3. Okay, it should be 11. So it's 11. This 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we can also split with what else can we? Let's split with a comma, right? So there's just one comma here. Let's intentionally add a comma, even if it doesn't make sense, just to see what it's going to give us. So there's a comma here, this will be one element. There's a comma here, this whole thing will be one. There's a comma here, this whole thing will be one. There's a comma here, this whole thing will be one. That's what happened here. So we have one, two. We expect to see four, right? Okay, this can you see that space? It's regarded that space here. So that's just it. All right, let's go ahead. Okay, let's build this project in which that we need to extract the date component from a particular date in this format. So let's say the date is, so by the date component, I mean the year, the month, and the day. So let's say the dates, we want to receive some data from a user, and that's why we're using the input. Then we have this as a prompt before the dialog box. Let's say the year will be the straight column, and then there's this column, straight bracket, there's a column, and there's four. That's from 0, 1, 2, 3, right? And then going to be um dates, straight brackets, and you could use the reverse slicing or the positive. I mean, you could use the negative slicing or the positive slicing. But if this is 3, this is 4, this is 5. So you want to start from 5 and end at 6. And they would be equal to 8. Um, okay. So it just extracts the. So I think there is some form of mistake here. This should be 7. So it gives us 5 and okay. Add the component. Add the let's call this here. Mm, mm, okay. Something is missing. This should be 10. Here is another simple project or a mini project. This could be applicable to social media content moderation. For example, you have people writing stuff on your post and you really want to scan through real quick to find out if there are words that are offensive or to flag down some words or text written in. This is one thing that could be useful. Um, the word I just had just some random statement written out here and saved in this variable as text. Today was one of those perfect lazy Saturdays where time seems to slow down just enough to savor every moment. Started my day with a leisurely breakfast, pancakes with fresh berries and a steaming cup of coffee. The aroma filling the kitchen with warmth. Spent the afternoon diving into a new hobby gardening. It's amazing how therapeutic it feels to get your hands dirty and watch something beautiful grow. Feeling proud of my tiny herb garden already. There's just some comment that could be. So, do you want to have a word count? How many words were written, were typed in? This word count will help to sort that. So you have length of text or split. Remember, we say split is gonna split up every word in here by the space. So far there is a space after each of the word. It's gonna split it up, and this LEN is gonna count how many each of those are. So let's print word count. We have 76, right? Let's say the character count. Character count would count of all the letters and including spaces and whatever apostrophe, whatever that is written in the string will be counted, and that is 59, right? Let's see, what about sentence count? How do we count the sentence? The sentence count is going to split up, like we know that a full stop ends a sentence, right? So at the end of every sentence, there's a full stop. So we're going to separate the sentence based on the full stop and count how many elements that are separated based on the full stop, right? Let's print sentence count. Oh, there's an error. What's the problem? This sentence count is not defined. Okay, there's a mistake. Okay, so we have 4 sentences, and then let's print word frequency. Mm, okay, I see the error already. We have 3, so how many times does and appears in the sentence? Maybe you're looking out for a particular word that you don't want to see or that you are really looking out for. Maybe this could be applied to like scanning through resumes or CVs. You're looking for a certain word in the CV, and this should be some type of code that will be written to scan out some words that maybe appearing. Like want to see if and it was written in a sentence. We always need to do text dot count and then hate check. Let's check if the person wrote anything like I hate this or I hate that. So the hate check would help sort that out. And how do we do that? We just do text dot count as hate. So we're going to find, or let's say find instead of count. It says -1. That means it's not present. Or let's just say, we can also say index. If we say index, it's going to give us an error because it's not present. And if we say counts, it's just going to say 0. So that means hate was not included in the sentence that was stated. All right. So I'll end this conversation, this video by reading from the book of Jeremiah, chapter 33, verse 3. It says, call upon me, and I will answer you, and show you great and mighty things which thou knowest not. God wants us to call upon him, even if no matter what you think about him, if you think that he doesn't exist, or you think that he doesn't care, or you think that he cares, or you think that he hears you, or you think that you've asked too many times. He wants us to call upon him at every time. He wants us to depend on him. So let this be your sign to call upon God. Let this be a reason for you to call upon God again. Thank you and see you next time. Bye.